Good afternoon everyone. My name is Professor Sudke SS of SND COE and Research Center Evla, working as Assistant Professor at Electrical Department. Now we will discuss the subject of Advanced Microcontroller and Embedded System, in which we discuss the topic of Unit 3, that is CCP module and its applications. In this unit we cover the topics like period measurement using capture mode of CCP module and speed control of DC motor using PWM mode of CCP module. Now first of all we see the period measurement using capture mode in CCP module, in which the capture, compare and PWM modes are available in CCP module for various applications. It is a peripheral that allows the measurement and control of different events and also generates pulse width modulated PWM output signals. For the measurement of period, we use the capture mode in the CCP module. In capture mode, the module can be used to measure the duration of an event. Using the capture mode, we can measure the duration of any event which is in the electrical system or computer system of the waveform. In capture mode, the RC2 CCP1 pin should be configured as an input by setting the try SC2 bit. If the RC2 CCP1 pin is configured as an output, a write to the port can cause a capture condition. Then second, timer 1 mode selection. Timer 1 must be running in timer mode or synchronized counter mode for the CCP module to use the capture features. And after that, it is useful for measuring the period of any time duration in the electrical or computer system. Then the second application of the CCP module and its mode is that speed control of DC motor using PWM mode of CCP module. The main advantage in using a DC motor is that the speed torque relationship can be varied to almost any useful form. To achieve the speed control, an electronic technique called pulse width modulation, that is PWM, is used, which generates high and low pulses to vary the speed in the motor. A simplest method to control the rotation speed of a DC motor is to control its driving voltage. Then higher the voltage, higher is the speed of the motor tries to reach. That is, the motor speed is directly proportional to the voltage of the system or voltage given to the motor. In many applications, simple voltage regulation would cause lot of power loss on control circuit, so a pulse width modulation method PWM is used in many DC motor controlling applications. The ratio of on time to off time is what determines the speed of the motor. When doing PWM controlling, keep in mind that a motor is a low pass device. The reason is that a motor is mainly a large inductor. It is not capable of passing high frequency energy and hence will not perform well using high frequencies. Reasonably low frequencies are required and then PWM techniques will work. The lower frequencies are generally better than higher frequencies, but PWM stops being effective at too low a frequency. The idea that a lower frequency PWM works better simply reflects that the on cycle needs to be pretty wide before the motor will draw any current because of motor inductance. Then a higher PWM frequency will work fine if you hang a large capacitor across the motor or short the motor out on the off cycle. The reason for this is that short pulses will not allow much current to flow before being cut off. Then the current that did flow is dissipated as an inductive kick, probably as heat through the flyback diodes. Then the capacitor integrates the pulse and provides a longer but lower current flow through the motor after the driver is cut off. Then there is not inductive kick either, since the current flow is not being cut off. Knowing the low pass roll off frequency of the motor helps to determine an optimum frequency for operating PWM. The main advantage of PWM is that power loss in the switching devices is very low. When a switch is off, there is practically no current, and when it is on, there is almost no voltage drop across the switch. Power loss, being the product of voltage and current, is thus in both cases close to zero. PWM works also well with digital controls, which, because of their on-off nature, can easily set the needed duty cycle. Then using pulse width modulation, that is PWM technique, has several advantages over analog control. Using PWM to dim a lamp would produce less heat than an analog control that converts some of the current to heat. Also, if PWM is used, the entire control circuit can be digital, eliminating the need for digital to analog converters. Using digital control lines will reduce the susceptibility of your circuit to interference. Finally, motors may be able to operate at lower speeds if you control them with PWM. That is PWM technique. Then, when you use an analog current to control a motor, it will not produce significant torque at low speeds. The magnetic field created by the small current will be too weak to turn the rotor. On the other hand, a PWM current can create short pulses of magnetic flux at full strength, which can turn the rotor at extremely slow speeds. This is all about the how DC motor speed is controlled by using the PWM technique in the CCP module, or PWM mode in the CCP module. Thank you.